So in this lesson, we're going to talk about the properties of logarithms. So I introduced you to logarithms on the last class meeting. And so in this class meeting, we're going to talk about 3 properties of logarithms, and then we're going to put it all together. So in this particular property, you have a log base b of a product. When you have a product like that, you can separate it into log base b of m plus log base b of n. Now, these properties go both ways. Sometimes they give you a logarithm plus a logarithm, and they want you to write it as a single logarithm, and sometimes they give you a single logarithm, and then want you to break it up. So we're going to do both of those. So if you notice, our directions say condense into a single logarithm. So that's what we're going to do here. I have a log base 2 plus a log base 2. These base numbers have to be the same or the property does not work. So I'm going to write 1 log base 2, and then I'm going to take these values, and whatever they are, and multiply them together. So log base 2 of 28. And that would be my final answer. Here, I have a log plus a log, understood base 10s. We talked about that the last time. So I'm going to have my log, and then I'm going to take both of these numbers and multiply them together. So that gives me log of 100. Here, I have a log base 4 plus a log base 4, so I'm going to take these numbers, and I'm going to write 1 log base 4, and then I'm going to multiply 2x times 4x squared. Now, you can simplify that out to log base 4 of 8x to the third. You can actually multiply those together. So that is starting with a log plus a log and condensing it into a single log. Now, this one we're going to expand. When you expand, you're taking 1 logarithm and most of the time breaking it up into 2. Now, there are 2 factors of 6, 1 times 6, 2 times 3. I'm going to actually just demonstrate this with breaking 6 up into 2 times 3. If you want to use 1 and 6, that's fine. That would be log base 2 plus log base 3. Because according to the rule, if you multiply, you can split it into 2 separate logarithms. Now, several multiples of 45, but I am actually going to use 9 times 5. So that would be log base 7 of 9 plus log base 7 of 5. And for the last one, I have a visible product, 5 times x. So I'm going to split that 5 and that x. So log base 2 of 5 plus log base 2 of x. So that is a couple, just a very basic way of using the product property. So the quotient property works a little bit different. So if you have a fraction behind your logarithm, you can rewrite this as log base b of m minus log base b of n. Okay, these base numbers have to be the same or the property does not work. So in example 7, we're condensing to a single logarithm. So I have a log 3 base 3 minus a log base 3. So I want 1 log base 3 with a fraction behind it. Now, I can reduce that to log base 3 of 3. 24 divided by 8 is just 3. In the second example, I have log base 2 of 15 divided by 15. Because I have a log base 2 minus a log base 2, so I'm going to take these numbers and divide them. That does simplify down to log base 2 of 1. Then I have another one over here. So I have a log base 4 minus a log base 4, which is log base 4 with a fraction behind it. I'm going to take these 2 numbers and divide them. So x to the 9th on top, x squared on the bottom. And that does simplify down to log base 4 of x to the 7th power. Now, I'm going to go the opposite direction. I am going to have to expand this time. So in number 11, I'm going to come back to number 10. In number 11, I have a fraction. So I'm going to write a log base 5 of 1 numerator minus log base 5 of 3, which is the denominator. The denominator always follows the subtraction sign. In number 12, I have log m minus log of 7. Now here I don't have a fraction, but what I'm going to do is I'm going to rewrite this as any fraction that would reduce to 4. So you could do 8 over 2 if you wanted to do 16 over 4, if you wanted to do 20 over 5. You could even do 12 over 3. All of these fractions reduce to 4. I'm just going to use the first one, log base 8 of 8 over 2, because 8 over 2 is still a value of 4. So now I can separate that to log base 8 of 8 minus log base 8 of 2. The third and final property is the power property. And it says if you have an exponent, you can pull it out in front and make it become a multiplier. So I can multiply n times log base b of m. Notice that my exponent is now out in front as a multiplier. So you can go both ways. I'm going to take this exponent, put it out in front. So that's 7 log base 2 of 8. I'm going to take this multiplier, put it out in front. Now be careful because there's already a multiplier out there. So technically I'm going to multiply both of those together. And that would give me 3x minus 3. Keep the grouping symbol. Log base 4. And here, this one is special because it's got a square root. The square root of w is equal to w to the 1/2 power. So I'm actually going to rewrite that. You do not want the square root in your problem. So I'm going to rewrite that using the fractional exponent. And we did discuss that earlier this semester. So go back in your notes and look. Now I'm going to move that 1/2 and put it out in front as a multiplier. So in examples 13 through 14, I know I went backwards, we're going to condense. Condensing means taking the multiplier and putting it back as an exponent. So that would be log base 4 of 2 to the 5th. You can leave it that way, or you can write it as log base 4 of 32. Two to the 5th power is 32. Here, I'm going to take my 7 and put it back as my exponent. So log base 2 of x to the 7th power. Now, I'm going to end up with a fractional exponent, which means there is a radical in my future. So 8 to the 1/3 power becomes the cube root of 8. So I end up with log cube root of 8. Now, I can actually simplify the cube root of 8. The cube root of 8 is actually log of 2. The cube root of 8 is 2. So I can simplify that one down a little bit further. Now, we're going to put these together, meaning we're going to write as the first group, we're going to write as single logarithms. And then in the second set of problems, we're going to write as expanded logarithms. So in the first example, I do see a power, so I want to deal with that power property first. So that would be log base 6, or log of 6 squared minus log of 9. Now I can take 6 squared and turn it into 36. And since I now have a log minus a log, it produces a fraction of 36 over 9. And that reduces to log of 4. In example 20, I have 2 powers that need to be dealt with. So I'm going to always try to deal with those powers first. That would be a to the 4th plus log base 4 of b squared. Now that I have a log base 4 plus a log base 4, I have 1 log base 4 with a to the fourth times b squared behind it. In example 21, I have a multiplier, so I'm going to put that multiplier back. Here, I've got a multiplier, so I need to multiply those two values together, the 3 and the 2. So in the first scenario, I get log base 4 of u to the 7th power minus log base 4 of v to the 6th power. Since I have a log base 4 minus a log base 4, this is going to give me a log base 4 of a fraction. So I'm going to take this value and divide it by this one. So u to the 7th divided by v to the 6th. Since I can't reduce that fraction, I stop right there. Here, I have no power, so I'm just going to go straight across. A log plus a log ends up being log base 2 of 15 times 4. So I took these two from left to right and just condensed them. So that's log base 2 of 60 minus log base 2 of 6. Now I have a log base 2 minus a log base 2, which is going to give me a fraction, which is 60 divided by 6. So my final answer, once I reduce 60 divided by 6, is log base 2 of 10. In example 24, I do have a multiplier that I have to create an exponent with. So I've got log base 3 of 4 plus log base 3 of y plus log base 3 of 49 to the 1/2 power. Excuse me, I can't have a 1/2 power. So 49 to the 1/2 power is equivalent to the square root of 49, which is 7. So this simplifies to 7. So I'm going to rewrite that as log base 3 of 4 plus log base 3 of y plus log base 3 of 7. Now, since I have a log base 3 times a log base 3, or plus a log base 3 plus a log base 3, I'm going to use my power or product property to multiply all of those values together. All three of these values together. So my final answer would be log base 3 of 28y. In the next example, 24, I have to do what's in parentheses first. So log base 5 plus log base 5, that gives me 1/3 log base 5 of 8 times 27 minus log base 5 of 3. Now, you can multiply 8 and 27 together, and you get 216. So I have 1/3 log base 5 of 216. Now, I do have a multiplier, so I'm going to have to put that up as my exponent. So that becomes log base 5 of 216 to the 1/3 power minus log base 5 of 3. 216 to the 1/3 power, that becomes the cube root of 216. And the cube root of 216, if I'm not mistaken, is 6. Let me double check. Okay. So I'm going to replace that with log base 5 of 6 minus log base 5 of 3. Now, since I have a log base 5 minus a log base 5, I get 1 log base 5 with a fraction behind it. And I can reduce that fraction down to 2. So my final answer would be log base 5 of 2. So you can see how some of these have multiple parts and some of them are not as time consuming. So in number 25, I do have powers, or a power I need to deal with. So that's log base 2 of 4 to the 3rd power, which I will turn 4 to the 3rd power into 64, because 4 to the 3rd power is 64. I now have a log base 2 minus a log base 2. So I get 1 log base 2 with a fraction, 64 divided by 32, and that will reduce to log base 2 of 2. And in the final problem, I have 2 multipliers that need to be addressed. So I have log 6 squared minus log 16 to the 1/4 power plus log of 3. Now, 16 to the 1/4 power is the 4th root of 16, and the 4th root of 16 is equal to 2. So I'm going to change this to a 2 because I have simplified it. So in the same step, I'm going to go ahead and do 6 squared, which is 36, minus log of 2 plus log of 3. So as I read from left to right, I'm going to do the subtraction first. So log 36 minus log 2 is written as a fraction, 36 divided by 2. And then I divide 36 by 2, I get log 18 plus log 3. And then this becomes multiplication. So log of 18 times 3, and that will give me a final answer of log 54. So that is several condensing. We started off with multiple logarithms and we worked our way down to 1. Now, in the second set and the final set for this particular lesson, we are going to expand, which means we're starting off in every single problem with 1 logarithm, but we're going to end up with multiple logarithms. So the first thing I'm going to do, I have a product, x times y times z. So I need to split that up into 3 separate logarithms joined by addition. So log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th. Now, the last thing I have to do is I have to use my product rule, or my power rule, to move my 4 to the front as a multiplier. So log base 6 of x plus log base 6 of y plus 4 times log base 6 of z. And that would be your final answer. You went from 1 logarithm to 3 logarithms. In our second example, I have a fraction. So fraction means I'm going to write 2 logarithms using subtraction. So a to the 9th, log base 4 of a to the 9th minus log base 4 of b. The only thing I can do here is move my 9 to the front. So that's 9 log base 4a minus log base 4 of b. And that would be my final answer for number 28. Now in this problem, I have this power out in front, so I need to move it to the front, or this power, which needs to be moved out to the front. So 2 times log base 7 of q to the 4th times r squared. So I dealt with my power property first. Okay, now I'm going to use my product property to separate these, but notice I'm keeping them in parentheses because this 2 goes to the whole problem. I am using a plus because it is a product. And then with inside the parentheses, I need to move those powers to the front. So my final answer for number 29 would be 2 parentheses 4 log base 7 of q plus 2 log base 7 of r. And that would be my final answer. Here, same thing. This 2 goes out in front, so that would become 2 times the logarithm of base 2 with that fraction y divided by 5. So I'm now going to take all of this and rewrite it as 2 separate. But remember, that 2 goes to all of it. So 2 times log base 2 of y minus log base 2 of 5. I use a minus sign because I do have a fraction. And that would be my final answer. The last 2 examples, notice they both have radicals. So the first thing I'm going to do is get rid of the radical. So I'm going to rewrite this. Notice the radical is above the 7 and the x to the third. So I'm going to keep 7x to the third in parentheses and put my fractional power out there. Then I'm going to move my fractional power to the front. That's 1/2 times log of 7x to the third. Since I'm multiplying 7 and x to the third, I'm going to leave that 1/2 out in front, and I'm going to split this into 2 logarithms, a log base 7 plus a log base x to the third. Now, the absolute last thing we have to do is take that inside power and move it to the front of that particular logarithm. And we are done with that problem. So the final problem, it does have a radical over the whole thing. So I'm going to rewrite that as log base 3 of m to the 5th n squared to the 1/4 power. I'll move the 1/4 to the front. And since m to the 5th is being multiplied by n squared, I'm going to separate that with addition. So that would be log base 3 m to the 5th plus log base 3 n squared. And then, of course, at the very end, I'm going to take both of those powers and write them as multipliers. So I have 5 times log base 3 of m plus 2 times log base 3 of n. And that would be my final answer. So that is multiple looks at the 3 different properties of logarithms, the product, the quotient, and the power. If you have any questions, please feel free to contact me.